Okay, well, welcome everybody. We're going to look through paper 3 now. Let's not waste any time and crack on. So number 1, 72 is a prime. Factors. You can do the table method. I always prefer doing the factor tree. So let me zoom in quickly. So think any two numbers that tiny give 72. For example, 9 and 8. Whenever you get a prime number, the idea is to circle it. 9 is not prime because we can break it down into 3 and 3. Circle both of those. 8 is 2 and 4. 2 is prime, 4 is not. And then let's wrap it up with 4, which is 2 and 2, right? So we've got all the prime factors there circled. Don't forget, though, product means you need to show that the whole point of this is you get 72 by multiplying all of those 5 numbers together. So don't forget to say 72 equals, and then all those numbers times together. I always like to write them out in full first and use powers then second. The reason I like to write out in full first is if you get powers wrong, a lot of the time the full answer is enough to get you full marks and you don't get penalised for writing the powers out. Okay, but yeah, that's the answer there. 2 cubed times 3 squared. Good start. B. All right, so the HCF of 72 and 108. I mean, you could write a list of all the factors. You might be there for a while. You know what? Since we've done this bit here above, I'm going to do the same with 108. So 108, do this quickly, is 2 and 54. 2 and, because it's even, and 27. 3 and 9. And 3 and 3. Now, HCF, the way it goes really is if you draw a Venn diagram, actually you don't really need a rectangle for these Venn diagrams, but I want to put all the factors of 72 here, 108 here. The HCF's the middle number, so what numbers do they share in common? So let's compare. Right, they both got a 3 each, so you only write that once. They've both got, actually they've got a pair of 3s, and that's it. They don't have any more 3s, but they do have an extra 2. So, do they have anything else in common? My apologies, there is another 2 as well. Okay, I almost forgot that. But that is it, right? Because the other one's got 2 and the other one's got 3. They're not common. So if you times these numbers together, you do get the HCF. So 2 times 2 is 4. Well, let me run my working out. Even as obvious as this is, and you can do in your head, always write it out first. 2 and 2 is 4. 3 and 3 is 9. And 4 times 9 is 36. 36 is your HCF. Well done if you got that. And yeah, it kind of makes sense, right? Because 36 goes into 72 twice and 36 goes into 108 3 times. So that seems like a reasonable answer. Number 2, scatter graphs. We like a good scatter graph. Okay, right, I have to clip this. So for question 2, we've got a scatter graph. Very clearly we can see off the bat it's positive correlation. Yeah, so let's start by saying that. Positive correlation. I've just realised I've skipped part A. So part A gives you this, and you've got to mark it. So many people skip this question. I almost missed it. Just goes to show you how important it is to read the questions carefully. So there's one person who got, Judge A gave them 4.6 and Judge B gave them 3.8. So let's mark them. So go across 4.6 and up 3.8, which is, again, do this accurately, otherwise you may not get the mark. Here. Right, for me it's a bit tricky, just because it's on an iPad, but I think that's good enough, right? That you can be a square out, although I wouldn't recommend it. Part C, right. It's asking us to estimate from a scatter graph. So what you want to do with a ruler is draw a line of best fit. That's a line that has roughly half the points on one side and the other. Now, this is a bit of an art here, so get a ruler. You'll notice your line of best fit doesn't actually have to go through any points whatsoever, but what we're looking for is a trend, a line that sort of represents trend of data, and it's got roughly half the points on one side and half on the other. So back to the question, it says, Judge A gave 3.7, so we'll go to Judge A 3.7, which is here, and go up with a ruler 3.7 until we hit the sort of line of best fit we drew earlier, and then go across. I think I'm reading 3.2. Again, I'm doing this without a ruler, which is not ideal. But yeah, we would expect that student to get 3.2 from Judge B. Okay. Moving on, question 3, trapezium. So, this is not an area question. At least it doesn't look like it. So I was thinking the area of a trapezium, but actually this is not necessary. There's a length question. So once AB, that line there, how are we going to find it? Well, we're going to split it into two shapes, right? A triangle and a rectangle. So let me redraw that triangle, because that's what we really want, right? We want the sort of length there. And this is a right angle triangle we've just drawn. Now this side, the bottom side's 6, because it's exactly the same length as the bottom. Now this side, on the right side, we've got to subtract 13.2 from 8.2. Sorry, 8.4. So do show that in your working. Again, you are allowed to calculate for this one, so don't really take any chances. 4.8 is the length. So we'll add that to my diagram. And to find that length, this is a Pythagoras question, isn't it? So let's do 6 squared plus 4.8 squared, because we'll find the hypotenuse, and we'll square root the answer. Okay, so it's 6 squared, I'm doing this with my calculator, plus 4.8 squared. And I'm going to square root all of that, which gives me 7.6 to 1 decimal. Sorry, 7.7 to 1 decimal place. It's 7.6837. I always think it's good practice to sort of write out the calculator display and then round it underneath. Okay, but that's the answer number 3. Number 4, make H the subject basically means we want H equals at the end, right? Not K. So we'll start by expanding the bracket first. I'm going to times 3 by everything inside that bracket. That would be 6H minus 3. Cool. Then I'm going to move the negative 3 across, right? Meaning I add 3 to both sides of my equation. I've now got K plus 3 equals 6H, because I've added the 3 to both sides. To make H the subject, it doesn't matter if it's H on the left or on the right on its own, it works either way. I'm going to divide by 6, so it's K plus 3, all of it divided by 6, so right fraction over 6, job done. So I always think it's a nice touch once you've done this to have it. Personally, I like H on the left, even though the previous line should be enough to get you full marks. This is a nice touch. Okay, but that's the answer there. Moving on, number 5, we've got perimeter of... Okay, we've got rectangle, semicircle joined together. Perimeter of the rectangle is 64. The length of AB to BC is 3 to 1, right? So let's think about that rectangle. That means for 3 parts here, 1 there, 3 there, 1 there. That's, again, these are not lengths, these are parts I'm thinking about here. So the rectangle has in total 8 parts, right? 3, 1, 3, 1. And the perimeter is 64, meaning those 8 parts represent 64 centimeters. So if I divide both by 8, each part of this rectangle I've drawn is 8 centimeters, meaning the side is 8, but the width is 24, right? 3 lots of 8, 24. So these are the lengths on my rectangle. So I've got 24 and 3, 24 and 3. Cool. It wants the area of the shape. Okay, so look, the good news is the area of the rectangle should be at this point quite straightforward. The area of the rectangle is just width times length. So it's 3 times 24, which, using my calculator, is 72 centimeters squared. Now the semicircle is slightly harder. Okay, so this semicircle here, I'll use purple. Now we know the height of the rectangle is 3, meaning the radius is 1.5. It's just half. Now I know the area of a circle. I know it's a semicircle, but bear with me. The area of a circle is pi r squared. So if I had both halves, I'd use this formula. And I'd say pi times 1.5 squared, which 1.5 squared times pi is 7.06. Now we've only got half of this. We've only got the semicircle, so let's divide that by 2. So the area of semicircle is, I'm going to just divide that by 2, which gives me, let's see, 3.534. 3.534. So the last step is really the total area is these two numbers added together. So 3.534 plus 72 let's wrap things up. Did I say 74? I meant I had 72. So the total area, let's pick a different colour. Red is, and again, you want to show this as an examiner, so you want to do 72 plus 3.534. I know we've written these two numbers already, but you're showing examiner I'm adding these. So the final answer is 75.5 centimeters squared. That's my final answer to 3SF. Okay, well done if you got that. Moving on, part B. The ratio is now reversed. Ooh, how does this affect the area of the shape? Well, okay, imagine this. So, I mean, if we think like as a sort of an image, it's kind of like rotating. So if we said 3, 1, 3, 1, the sort of rectangle's on its side now, isn't it? And the semicircle's going to have a much bigger radius. In fact, it'll be half of 24, right? It'll be 12 centimeters. So we can say the total area will increase as rectangle is the same, but the semicircle has a larger radius of 12. Right, because it's only a 1 marker, it's not expecting you to actually work it out. If you did that, you probably will still get a mark, but you're kind of wasting time here when you could be spending on other questions. Number 6, right. Solving a quadratic, so we want two numbers. Remember, team, two numbers are multiplied to give -8, add to give +2. I'm thinking 4 and 2 definitely work as my two numbers. I've just got to think about what signs, because 4 and 2 we give 2. Right, I want a +2x, so I think the negative will be the -2 and the +4. Okay, so that's me factorising first. That's the first mark in the back. Remember, we're solving, so remember that means each bracket is 0. So for the first bracket to be 0, x would have to be -4. Or for the second bracket to be 0, x would be +2. So here are your two answers for number 6. It's a very textbook question, solving quadratics. Okay, this one, if it looks confusing, it really isn't. It just means 3 lots of this vector minus 2 lots of this vector. We just times everything in the first vector by 3, so you've got 9 and 12. And the second one we're going to multiply by, we'll keep the -2 outside the bracket, we'll just times everything by +2, so 2 and 10. So we just subtract the second vector from the first, so 9 take away 2 is 7, and 12 take away 10 is 2. Why am I writing 10? Okay, that's your answer for number 7. Moving on. Right, number 8. Here are... Okay, so y equals x is classic shape. It goes through 0, 0. Basically means what line are the x and y coordinates the same, right? So you can say, right, 1, 1, 2, 2, 3, 3, 4, 4. That's going to be graph D all day long. Y equals 2 means on what graph is the y coordinate always 2, right? It's the vertical. Any point you pick on this line, the y coordinate's going to be 2, right? It's a horizontal line. That's C. Y equals x squared, that's got that sort of unique U shape. So anything with x squared or minus x squared will be a U or a sort of upside down U. So in this case it's B. And by process of elimination, 8 is A. The lot minus x is A. It goes down instead of up because of the negative. Okay, so it's DCBA is the answer in the right order for 8. Number 9, right, Fuchs polygon. Right, Fuchs polygons are easy if you know what to do. So we want to pick the midpoint of each of these as my x-coordinate, so 2.5, and the y-coordinate's 2. Careful the scaling here, because each 5 boxes on the y-axis represent... Each 10 boxes represent 5, so each unit's 2 boxes. So for the first point, I want to go... No, I'm not accurate because it's on an iPad. So let me rub this out, let me make it better. So the first one, midpoint is 2.5, y-coordinate is 2, which would go there. Next one, 7.5 with 5 up there. The third one, this point here, 12.5 and 15, which is all the way up here. 3 more to go, sorry, 17.5 and 12, which is here. Last two, 22.5 with 11, and last point, 27.5 and 6, which is here. Okay, so just all you got to do now is join the points together, left to right with a straight line. I'm not using a ruler because it's on my iPad, but please do with a ruler. Whatever you do, do not join the first and last point together. If you do that, you will lose marks, so please do not do that. Last one asks for the median. Okay, now we've got 51 people. So if we lined everyone up, the median would be, we add 1, we divide it by 2. So it's going to be 52 divided by 2? It's going to be the 26th person. So which group would the 26th person be? Well, the first 2 are here. Then the third, all the way up to the 7th, would be here. I'm doing the cumulative frequency here. Then the next 15 would bring me up to the 22nd person would be here. And then we'd have the 24th, 25th, 23rd, 24th, 25th, 26th, 27th, 28th, all the way up to the 34th person. So this is the group with a median. I want to write 15 to 20. All right, so 15 to 20 is my class interval. It just wants the group with the median in. All right, Terry says, at least one of these people spent 30. Is he right? No, not necessarily. No. Since data is grouped, we do not know exactly how much money, just trying to scroll up here, the 6 people spent. Could be more. Yeah, we could have all 6 people spend £30. We could have 0, right? Because obviously they can spend anything ranging from £26 or £25 and 1 pence, or so we don't know that for sure. Okay, right, so this is error interval is the name of the topic. It's rounding in reverse. So if a number was rounded 7.28, what's the biggest and smallest it could have been? Well, the smallest it could have been would be 7.275. Because if you round that number to 2 decimal places, it rounds up. The maximum would be 7.285. Now, before you say, oh, wait a minute, sir, wouldn't that round up to 7.28, 7.29? This is where the inequalities come in. So notice how I'm saying strictly less than 7.285, meaning anything less than, but not including that exact number, is fine. The left number's fine, so I'm writing an equal sign, so because it could actually be 7.275. Chuck an N in the middle, that's your error interval. Job done. Right, next up we got compound interest. We are saving money in the savings account. Dan, what a great name, is investing that much money, 14 grand. All right, so this is best answered by using multipliers. So I'm going to take £14,000. In the first year, if it goes up 4%, that means I'm multiplying it by 1.04. Now, in the second and third year, we're going to just say, I'm going to avoid using the letter X here. I'm going to just say Y. So we're multiplying by some number Y for the second year, and we're multiplying it by that same amount again for the third year. And as a result, at the end, we are left with £15,297.10. Cool. So look at this. We are going to get y squared. And you know what? With all of this number, I'm going to divide it across. So y squared is going to be £15,297.10 divided by that. Again, don't worry if you times the numbers first on the bottom and then divide it. It works. So let's work this out. 15297.10 divided by, I always like to use a fraction button here, 14,000 times 1.84. And my calculator is giving me this. Y squared is 1.050625. Now, to get y, which is the yearly sort of multiplier, we square root this. So let me square root all of that number. I'm getting 1.025. Now, remember, multiplier is like the 1 is the 100%. it's the 2, 5 at the end, which is the percentage, isn't it? So we can deduce from this, the end bit, it's got to be a 2.5. That's 2.5%, isn't it? Hiding at the end of my multiplier. So X percent equals 2.5%, right? Is how much the money goes up in second and third year. So that's my value of X, 2.5. Number 12. Oh, okay, multiplying triple brackets here. So this one, if I times this double bracket out, I'm going to get X squared plus X minus 2. All right, I've simplified in my head here. In the real exam, please do that. And then I've got X plus 3 at the end. Okay, so I'm going to times it, all the first 3 terms by X first. So I'll get X cubed plus X squared minus 2X. And I'm going to times those 3 things now. Instead of by X, I'm going to just times them by 3. So plus 3X squared plus 3X minus 6. Cool. The last step is for me to just collect like terms. So there's only 1X cubed. There are X squared. There's 1 there and 3 there. That's plus 4X squared. I've got minus 2. Add 3. That's just 1X or just X. And then minus 6 at the end. So that's my answer. So that's A, that's B, that's C, that's D. You don't have to actually say what they are, but they are whole numbers, they're integers, so that's reassuring. Number 13, that's cool. Right, A, B, C, D are on a line. Okay, I'm going to just do a sketch of the line A, B, C, and D. Imagine, like, they're not equally distant apart, that's just my sketch. Okay, but from A to B, so from A to B, that's 1 part, and from B to D, it's 2 parts. Okay, now from A to C, it's 7 parts, and from C to D, that's 2 parts. Okay. All right. So look, notice one of these ratios is 9. So look, the 7 and 2 is 9 parts. The other one is 3 parts. Right. Do you know what I'm going to do? Oh, so yeah, the lowest common multiple, if I think about total parts, that's 9, that's 3. The lowest common multiple is 9. So what I'm going to do is I'm going to write the top ratio, instead of being out of 3 parts, I'm going to multiply them both by 3 and have them out of 9. So if it's 1 to 2, it's the same as saying if you times both by 3, you'd get 3 to 6. The reason I've done that is that now they're both 9 parts on the top and bottom. So if I draw this vertically, think of it this way. Here we've got A, B, C, D. So look, the difference between A to B is 3 parts, and B to D is 6. The bottom part is A to C is 7 parts, and this is 2 parts. Now we can start subtracting stuff. So look, if A to B is 3 and A to C is 7, well then clearly this bit has to be 4, right? Because 3 and the 4 have to add up to 7. And we've got C to D already, which is 2. So the ratio of AB to BC to CD is literally 3 for AB, BC is 4, and CD is 2. There are other ways of getting this, but again, this is one way. As long as you're getting 3 to 4 to 2, you're good. Number 4. Okay, right. Now, inequalities, usually you have to draw the straight line. So x plus y equals 3. You can do a quick table if you want, pick values of x, and then just say, look, I know it's an inequality, but you're just thinking, right, what if it was an equal sign, what would that graph look like? Well, if x was 1, y would have to be 2, because remember they have to add up to 3. If x was 2, y would have to be 1. If x was 3, y would have to be 0. In fact, it's going to be a line that goes through the x and y axis at 3. Now, because it's strictly less than 3, you have to be careful and draw a dotted line. Oh, don't know where that came from. Let me write that out. But yeah, we're going to draw a line because it's actually not, as far as inequalities are concerned, we're not actually allowed to pick any number on this line, but we're allowed to pick, pairs of numbers of x and y that are less than. So that is dotted. Cool. Moving on. Next question, or next line is x equals 1. Now this is the line where all the x coordinates are 1, so it's a vertical line, again dotted down here, because anywhere on that line that you pick, the x coordinate will be 1. Next up, y is greater than -2, so same thing, but just with y being -2 this time. And last but not least, this is probably the trickiest one to draw. You might even need to do a table of values for this last one. So again, pick different values of x. Pick easy ones like 0, 1, and 2. You're just timesing by 2, taking away 1. So 0 times 2 is 0, take away 1 is -1. Next one, 2 times 1 is 2, take away 1 is 1. And lastly, 2 times 2 is 4, take away 1 is 3. Let's plot these coordinates. 0, -1, which is down here. 1, 1 is up here. Apologies, I got the first point wrong. 0, -1 actually is here. 1, 1 is here. 2, 3 is up here. And again, it's, if we had the extra line like that, it would be a solid line. But because they're all strictly greater and strictly less, we have to do dotted lines for all of these. So almost done now. Now we've got an inequality here, right? So coming back to this, x and y less than 3. If you want to know which side of the line that's talking about, pick a random pair of coordinates. 0, 0 is probably one of the easier ones. Is 0 plus 0 less than 3? Yes. So this one wants things on this side. So we can sort of scribble this out. That I don't want that, because on that side, x plus y would be numbers bigger than 3. Let's go to the next one. This one here, x greater than 1. So basically things to the right of this green line is what I want. The blue one now, the y is greater than -2. Basically anything above this line here on the bottom is good. And last but not least, this is the harder one. 2x minus y is less than 2x minus 1. Well, if you pick 0, 0, 2 lots of 0 take away 1. So if I do the x coordinate 0, I'd get 0 is less than -1, which is not a true statement. So this is basically, that means that's not the side I want. So get rid. So again, it's a bit messy here on my drawing because I've done lots of different colors. But the area we want is below this line, sort of to the right of this green line here, below this and above this. So this line here is R. This is the region I want. Right, it's a bit tricky that. Well done if you got that. Number 15. Okay, so this topic is called capture recapture. It's quite a popular question. So think about it this way. Polly catches 200 fish. So we'll say the number of fish in the lake. We'll say we don't know what it is. We'll just call it X, right? So if Molly is, think about this first line. The fraction of fish she catches on day 1 is 200 out of X, the total number in the lake. Now, what we say about this fraction is, well, this fraction actually should be identical, right? So what fraction, well, if she's catching 15, she caught 15 out of 90. So the way capture recapture works is we say 15 out of 90 is the same as 200 out of the whole lake. So that's sort of your starting point. That's the first fraction you want to write. To solve this, you want to rearrange to get X, and that will give you the number of fish in the lake. So the easiest way is you sort of cross multiply the X to get 15X. You cross multiply the 200 by 90. And obviously X means you need to divide by the 15. So the working is this. Again, if I type this in my calculator now, 200 times 90 divided by 15 is 1,200 fish in the lake. Cool. Number 16, Jeff. My name is Jeff. A little throwback to a few years ago, that reference there. Number 16. It's a shaped one. So we've got a cone and a hemisphere, one stacked on top of the other. Radius. Okay, a lot of lengths. bit ratio. Okay. Okie dokie. Right, we'll start by finding the volume of the cone. So the volume of the cone is 1/3 pi r squared h. And luckily we are given r and h. So let's just substitute away. Let's go pi times 3.6 squared times 12. So do you know what? I'm going to leave this in terms of pi, just because I like it. You know, if you do this, it does stay accurate. So what I'm getting is 51.84 pi. We'll keep that for now. So I might need the space to do a bit more working, but let's keep that up there for now. Again, if you want to see the working I did for this, you can just rewind. But I want the area so I can do the rest of what I need to do here. Okay, what else do I know? They're mathematically similar. A and B. So we've got... so now we need to do the same for the hemisphere on the top. So a sphere is this. So we know the radius is 3.6. So we've got 4/3 pi times 3.6 cubed, not squared, but cubed for the sphere. And then we're going to have to halve that answer, right? Because it's only half a sphere, not a total one. So let me do a bit of calculator work now. Let's see. Okay, calculator didn't like it when I did that. Let me try again. And I'm getting 31.104 pi. Again, I'm going to keep in terms of pi. So look, let me add these two together. So I'll get my total volume of model A will be these two numbers added together. 51.84. I've got 82.944. 82.944 pi. Okie dokie. Right. Now, with volume, and again, this is sort of the difference between this is the linear scale factor equals 2 to 3. But when we do volume scale factor, it's really important we have to cube both of these numbers, right? So 2 cubed becomes 8 and 3 cubed becomes 27. Okay, so it means instead of sort of going up by 1.5 times, it's got to go up by substantially more, right? Actually over 3 times larger. So one way of looking at this, if I divide both sides by 8, it means that in model A, for every centimetre cube worth of volume, it's going to go up by 27/8. You know, you can write this as a decimal if you want. So the volume of B is going to be this number multiplied by that fraction 27/8. Okay, so times 27 divided by 8. Now I've got, and again, this is still in terms of pi, 279.936 pi. That's the exact answer. But of course, at this point, I think it wants, 3SF is going to be 879.44488 ... more to it, right? But the 3SF, it will be 879 centimeters cubed. Right, well done if you got that. Well done to Jeff. Legend. Number 17, right. Oof. So it looks like quadrilateral. We're going to work. So we've got to work out the angle ABD, 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 ABD. That one. Okay. How are we going to do it? Right, we're going to have to work out the length of this line first. If we ignore the top triangle and we focus on that one, we're going to use the cosine rule. Yeah? Ignoring the top triangle, if I kind of sketch out what's going on here, I want to work out that. I'm going to work out that length. This one I know is 10. This one I know is 8. And 75 is your angle. Okay, let's go. Let's use the cosine rule. This is the first step. So remember, I'm not going to write the whole formula out in full. So it's a squared equals b squared, which I'm going to say is 10, plus c squared at 8, minus 2bc, so 10 and 8, cos of 75. Or cos of capital A, which is the opposite angle to length A. Okie dokie. Right, so bit calculator work for you. So 10 squared plus 8 squared minus 2 times 8 times 10 times cos 75 gives you 122.58. Do not forget to square root this number. This is only a squared. A is the square root of that, so let me do that. I've got 11.1. I'm going to round it to 3SF. It's actually 11.071, but I'm just going to keep it to 3SF. That should be fine. And at this point now, we can switch our attention to the top triangle. So I'm going to rub this out. Just give me more space. Rewind if you want to read what that said. Okay. So we want this angle here. ABD. Right. The good news is we don't have to use cosine anymore. I'm going to call that capital A. I know it's on vertex B, but we've got 5 there. We've got 11.1 there, and we've got 135 here. Right. There are different ways to get the answer, but for me, the most practical is probably sine rule. So remember, it's sine of capital A, which I'm saying is this side, divided by 5. Again, you can decide what A, B, and C are depending on every time you use this formula. Doesn't have to be the ABC they say in the question. Equals sine 135 over 11.1. Right, let's times across the 5. And then don't forget to do the inverse sine of all of this. So it's a bit of, yeah. Don't worry if you sort of process this step by step. I'm sort of writing them working all out at once. But the final answer is shift inverse sine of 5 sine 135 over 11.1. Again, don't forget to close your brackets. I'm getting 18.6 to 1 decimal place. It actually says 11.573. Again, actually, it's always a good idea to write the full length, because if you make a mistake rounding, they might still give you full marks if they're feeling generous. Number 18, right? This is called induction, or iterative process rather. It means usually take the year or the last 2 years and combine values and do stuff to it. Okay. Okay, so in 2018, we are told this is V1. So in 2018, the population was 375. Now, what this formula means is if you want to work the n+1, basically the next year along, you take the previous year and you times it by 0.8. So remember, this is 2019, and it means we take the previous year, 375, and we multiply it by 0.8. So again, quite straightforward. It's going to be 300. So 2020, you take the previous year, 300, and you times it by 0.8, and you get 240. And then V4, 2021, 240 times 0.8. Now, hopefully it's a number less than 200. If it is, then we're flying. It's 192. So that's our answer. Yeah, we've shown that at the beginning of 2021, sorry, it's 192, done. 19, distance times graph. We like a good distance time graph. Estimate the gradient, right. So an estimate means gradient at 5 minutes, which is right here. You need to use a ruler. The gradient at this point is, don't just pick 2 points on the curve. You've got to sort of use a ruler and draw a tangent. That's a line that hits your curve at only 1 point. If I had a ruler, I promise you I would have done a lot better. So now you can pick any 2 points on that tangent you've drawn. Let's go. I'm going to go with this point here. It looks nice. And let's go here. That looks nice as well. And we do rise over run, right? So gradient is usually this formula here. x1 minus x2. So, you know, that y coordinate's 30. Take away that y coordinate, which is 0. Divided by that x coordinate, which is 10. Take away 3. So I'm getting, as a fraction, 30 take away 0 is 30. 10 divided by 10 take away 3 is 7. That's my gradient. Cool. And my answer to part A means the gradient is the acceleration. The difference in distance, hang on a moment, am I doing this right? So distance, hang on a minute, hang on. Is it, so I'm thinking velocity times graph is accelerated. So the difference in distance over the difference in time. Think about where you've seen the difference in distance and the difference in time. That's speed, isn't it? So it's the speed of, doesn't really give context, of the particle or object at 5 minutes. So at 5 minutes, it's traveling at whatever 30 over 7 is. This could be what, 4 point something meters per second, or kilometers per minute. Yeah, in kilometers per minute, right? Because that's what my x. So my y and my x are kilometers per minute. It's the speed. Cool. There's the second part. Speed time graph. So instead of distance time, it's now speed time. Estimate the area. Okay, so 3 strips. So between t is 2 and t is 8, we need 3 strips. So there are my 3 strips. Draw a straight line connecting them. So you basically get 3 trapeziums like that. And what you got to do is, the area is basically the area is just 3 trapeziums, right? So remember, it's half of a plus b, which is the parallel side. So this would be 4 and 6, multiplied by the length between them, which in this case is 2. So it's half of 4 plus 6 times by 2. Again, you know, do bid maths here. Half of 4 and 6 is 10 times 2. That's that. The half and 2 cancel each other out, don't they? So you get 10. Same idea here with this one. So it's a half of, be careful here, 6 plus 7. Oh my god, I did the thing. Don't panic, people. Times by 2. Again, use bid maths here. You're going to get 13. Last but not least, this last trapezium, you're going to do half of 7 and 8 times by 2, which is 15. So the area under the curve is these 3 numbers added together, 15, 13, and 10. Do show the examiner this, or you may not get the mark for method. So this could be what, 38 is your answer. Meters, which is the speed. Distance, sorry. So the area under the graph, basically you can argue, not that it's a question, but sometimes they want you to explain it. They say, what does that mean? You can say, well, between 2 and 8 seconds, they travelled 38 meters. Oh dear. For some reason, this page disappeared. While I'm on it, they often also like to frame a question is your answer an under or overestimate? I'm just thinking of popular questions in previous papers. You would say, oh, well, this is an underestimate because the real answer would have included these gaps, wouldn't they? Yeah, so if there's a follow-up question saying, is it an over or an underestimate, you say, well, this is 38, it's actually an underestimate. The real answer should be bigger. Fair enough. Number 20, we are getting towards the end now. If you made it this far, well done. Area of triangle is that. Work out angle ABC. Okay. Right. Let's call that angle X. A, B, C. Okay. I'm going to work this angle out because usually if you've got the angle in between and you've got the two lengths either side, you can use the sine formula for sine, which is area of a triangle is half AB sine C. So in this case, A and B are both 11, and C I've called X. I mean, you can call it C if you want, doesn't really matter. But we're told the area already, right? We already know the answer to this is 42.5. So let's rearrange. Half of 11 times 11 is 60.5. So we can say sine X is 42.5 over 60.5. If we do the inverse sine of that, we will get X. So let's do that. The inverse sine of 42.5 over 60.5. So that angle at the top is 44.626. Now, bear in mind that was not what the question asked for. But because it's an isosceles triangle, we can say these two angles are equal to one another. So to wrap this up, I'm going to do 180 minus that and halve the answer, right? Because you remember angles in a triangle, it's 180. So let's do that. Do 180 minus my answer divided by 2. And I'm getting, the final answer is, I can't believe my eyes, 67.7 degrees. Right. Okay, final question here. So you've got a circle theorem, and you're told that A and B are part of a diameter that goes through center O. And what you've got to prove that no matter where on this line, the angle that ACB makes is always 90. Let me just draw that a bit better. There we go. So how are you going to do that? And you're not allowed to just say, oh, angles in a semicircle is 90. So what the first step you want to do, and most proofs of circle theorems, and again, this is the hardest style of circle theorem question, is to prove it. Almost always, you want to draw a line going from, you want to basically try and add radiuses or radii. So the first thing you want to do is you want to add r. Then what we're going to do is we're going to label this one angle X. Now, importantly, if that's r, well, this is a radius, and so is that, right? So the idea is we've got plenty of radiuses, and you can definitely see lots of different isosceles triangles within your shape. So if this is angle X, I'm going to start by finding an expression for this angle here. So let me communicate to the examiner what I'm writing. So we'll say let angle COB equal X. Then, well, if that blue, if this is an isosceles triangle because we've got two radiuses, the two blue angles are equal. And what we can say is that we can say, well, angle OCB, because this angle's in a triangle, I'm going to say 180, take away the X. But of course, because I've got to share this result over two equal angles, I need to halve that. Yeah? Now we can sort of split the fraction up. We can say this is 180 over 2, which is 90, minus X over 2. All right? So we've got an expression for angle OCB. Now we're going to do the same, but we're going to do it on the opposite side. Okay? So then we're going to say angle this one at the top here. Well, if this is a straight line, if the green angle's x, then this is going to be 180 minus x because this angle's in a straight line. So we've got angle AOC is 180 minus x, meaning that this angle at the top, just like before, I need to do 180 take away this and then divide the answer by 2. So angle OCA is going to be 180 take away this. I'm going to use brackets here because I'm taking away the whole thing. And then I need to divide it by 2. So 180 take away 180, the 180s cancel out. But look, we've got minus x, which makes it a positive x, is this angle here. So this is x over 2. Ooh. So remember what we said earlier. We said the blue angle was 90 minus x over 2. And we're saying the orange one is x over 2. Now to wrap things up, which I'll write over here. So angle ACB, the thing we're being asked to show, is x over 2 plus 90 minus x over 2, which, by cancelling out the x over 2's, we are left with 80. So angle ACB is always 90 degrees. Right, hope you enjoyed. Don't forget to hit that like and follow. Thought I'd say that. But anyway, any questions, do let me know, and I'm happy to help.